Hi everyone, I'm going to go over section 4.1 called congruent figures. I know that you guys know what the word congruent means. It means same size and same shape. We've only really used it to talk about segments as well as angles, and now we're going to use it to talk about combinations of segments and angles, basically figures, specifically polygons. And the first type of polygon that we're going to apply it to is a triangle. So the second thing that I have here defined is congruent triangles. Two triangles whose vertices can be matched up so that the corresponding parts of the triangles are congruent. Now when I'm talking about the parts of the triangle, I mean, of course, sides of the triangle and angles of the triangle. The next thing that I've got in bold face here is going to be a very important part of this chapter, and it's the idea that corresponding parts of congruent triangles are congruent. And what I mean by that is that if I can tell you, for instance, that triangle ABC is congruent to triangle DEF, okay, then I know that angle A and angle D are congruent. I know that angle B and angle D or E are congruent. And I know that angle C and angle F are going to be congruent. Additionally, I'm going to know that segment AB is going to be congruent to segment DE, and that segment BC will be congruent to segment EF, and so forth. Now notice that I was looking at the order of the angles in the names of the two triangles to decide the congruent statements that I just wrote. I noticed that A was first and D was first, and then I made a decision that angle A would be congruent to angle D, not E or F. It matters what order you write congruent statements in when you're talking about congruent figures. Not so much with segments, not so much with angles, but in figures it will matter a great deal. That being said, if you look at these two triangles here, BUS and TOP, if we knew that they were congruent, and I'm adding in some markers to indicate that they are indeed congruent, okay, you would need to be careful about how you wrote a congruent statement. If, for instance, you chose to write the left triangle as triangle BUS, okay, once you write it as triangle BUS, you need to name the next triangle in a particular way so that the angles are matching up to the congruent angles. Okay, so if I've mentioned angle B first, then I need to mention angle T first in the other triangle. If I've mentioned angle U second, then I needed to mention angle O second because it's the corresponding angle. And then finally, S was last, and P matches up with it. So there you go. Triangle BUS is congruent to triangle TOP. Now, it certainly doesn't need to be in that order, BUS. It could have been USB. But if you change it to USB, then you'd need to change TOP to OPT. Okay, so that, triangle OPT. So that corresponding parts of the triangles are matched up. We have another one below where the triangles are not oriented in quite the same way, so it's a little more difficult. Let's use some highlighting here. We've got SN has one segment marker on it, as does TE, and SU has two segment markers on it, just like AE or EA, and then we've got UN kind of matching up here with TA or AT. So let's decide a way that we could name this. We could call the first one perhaps triangle SUN. If you choose that order, then the way that you need to name the next triangle, let's see, S was where the yellow and blue matched up. So the yellow and blue on the right triangle match up at angle E. And then U was where the blue and purple matched up. So the blue and purple match up at A. And then, of course, after E and A, there's only one angle left, and that would be T. We can extend these ideas to other shapes beyond triangles. So I have some pentagons here that are congruent. And 4 of the sides have been marked congruent to one another. And then that last side, this EK, it's not marked congruent, but you can see that the 2 polygons share it. If it's the same side, then of course it's congruent to itself. So we can presume that the last side's congruent. And we can go ahead and name this figure. Now, we don't typically use pentagon, a shape of a pentagon to name a pentagon. We'll just go ahead and start naming it by its letters, or by its angles. So let's decide to name the first shape B-R-A-K-E, B-R-A-K-E. And once we choose that name, we do need to name the second pentagon in one unique way so that the angles and sides are matched up appropriately. So let's see. If we started with B, angle B here, that was between the 3 markers and the 4 markers. That matches up to C over here. And then we moved on to R, and R was between 3 markers and 2 markers. H is between 3 markers and 2 markers. And then after that, I'm sure that you can see that we'll go clockwise around the shape, and it should be C-H-O-K-E. All right, so what I suggest when watching this video is that when it comes to examples, that you pause the video, try them yourself, and then once you've finished and you want to check your answers, you can restart the video. I'll continue on at this point. We're supposed to practice, and we know that triangle FIN is congruent to triangle WEB, so we're supposed to name 3 corresponding pairs of sides and 3 pairs of corresponding angles. Okay, so actually let's start with the angles. That's practically done for us just by seeing the order. Okay, seeing the order that FIN is matched up to WEB, and I know that angle F is congruent to angle W because they're both first. I know that angle I is congruent to angle E because they're both second, and I know that angle N is congruent to angle B because they were both third. Then as far as segments, okay, the easiest segment to do is probably the first 2 letters. So the first 2 letters of triangle FIN are F and I. So that must mean that segment FI is congruent to the segment formed by the first 2 angles in or points in the second triangle, which are W and E. Okay. Let's try the second and third letter in the name. That would be I and N, and that must be congruent to the second and third letter in triangle EB, or WEB, which is EB. And then finally, we'll take F and N, the first and the last, which would correspond to W and B, the first and the last. Now, in these segments, you can name them in any order. It doesn't matter. But if you choose F, then I, for instance, in this first statement, then W and E should also be in that particular order. Is it correct to say that triangle NIF is congruent to triangle BEW? NIF, well, let's see. NIF, let's compare it to FIN. It looks like we just went backwards. Instead of FIN, we went in the opposite direction, NIF. If that's true about the second triangle, then we can say that the congruent statement is true. So WEB, if you go backwards, would be BEW. And that's exactly what this says, BEW. So we can say yes, it is correct that triangle NIF is congruent to triangle BEW. Now, looking at the third question, is it correct to say that INF is congruent to EWB, or triangle INF? Let's go check out the original statement. I was the second angle named, and then N was the third, and then I was the, I'm sorry, let me back up for a second. I think I might have gotten that out of order. I was the first, or I was the second and became the first, okay? And then after I, we moved to N, okay? And then we went back around to the first. So I, then N, then F. if that's the same order that we changed WEB in, then that's fine. The second letter is now named first. Is E named first? Yes, we're good with the E. Okay. But then after that, the N should match up with the B. But unfortunately, in this statement, the B did not come next. It should be B to retain corresponding parts matched up. So since that's not the case, we're going to say no. Okay, that is not necessarily the case. Okay. Moving on, again, try these first, pause the video, and then go ahead and check your answers. Okay. Two triangles shown are congruent, complete. Actually, I should have told you in advance that this segment is congruent to that segment, and this segment's congruent to this segment, and then this is congruent to that. And then, of course, we know vertical angles are congruent. And so we can hopefully start to see the corresponding parts in these two figures. So if, let's see, RAW, okay, RAW, well, they share angle R, so R will come first, okay, and then we move along the short side, so that would take us to angle T and then angle S. It's easy to answer number 5 if you look back up at this statement here. Angle A is second, and it matches up to angle T. Segment AR, again, look at this congruence statement to help you. AR, that's the second letter, and then the first letter. So make sure that you go to RTS and take the second letter, which is T, and then the first letter, which is R, TR. And then go check your diagram. Does it look like, say, AR is congruent to TR? Yes. All right, then next, WR. WR is the third letter followed by the first letter. If I'm looking back here at number 4, okay, the third letter followed by the first letter. So take the third letter followed by the first letter from RTS, and then go check your work. I'll use purple. WR is congruent to SR. Yes, that makes sense. Okay. Can we deduce that R is the midpoint of any segment? Why or why not? The answer to this is yes. R is the midpoint of, let's see, that would be AT. Okay, definitely AT. Okay, because it splits AT in half into two congruent segments. Splits into two congruent segments. And anything else? Well, hey, look, WS. Also WS, same reason, splits it into two congruent segments, WR and RS. Explain how you can deduce that ST is parallel to AW. ST is parallel to AW. I'll mark that for you guys. Let's see, we've got a whole list of ways to prove that lines are parallel from our previous chapter, and those ideas were about corresponding angles being congruent or alternate interior angles being congruent, and also same side interior angles being supplementary. I don't see anything supplementary necessarily, so it's probably one of these two. I don't see any corresponding angles, but I do see the idea that, say, for instance, that angle A is congruent to angle T, okay, and those are on opposite sides of the transversal AT, okay, so since that's the case, ST is parallel to AW by, if alternate interior angles are congruent, then lines are parallel. So that's the reason, and the statement would be that angle A is congruent to angle T. Let's see, we also, if you wanted to do it another way, we know that angle W is congruent to angle S, and those two are also alternate interior angles, just on a different transversal, WS. So I could have said angle W is congruent to angle S by the same reason. All right, Suppose that you know that TA is perpendicular to TS. TA is perpendicular to TS. So let me erase this mark here and put in a 90-degree symbol here. Explain how you know that TA is perpendicular to WA. TA is perpendicular to WA. Well, we could do this by several reasons. There was one reason that we had that was kind of special. I said it was redundant. That the idea that if you have a transversal cutting through two lines, transversal cuts through two parallel lines, okay, then, and we had one perpendicular intersection, okay, the other is also perpendicular, okay. But we could also use the idea of alternate interior angles again, okay. These angle T and angle A are alternate interior angles, so when lines are parallel, alternate interior angles are congruent. Either or would work. Okay. All right, the pentagons shown are congruent. Okay, so we got to complete. Let's see. B corresponds to angle R. Okay. And therefore, let's see, if I call the left figure BLACK, BLACK, okay, I'm going to go around the other figure the opposite direction because it's flipped over here. So that would be ROHES. ROHES. Okay. Let's see, what would match up to angle E then? Well, angle E is fourth, angle C is fourth. So angle C, measure of angle C is equal to measure of angle E. KB. KB is here in blue, and that matches up to, let's see, SR, which I know is 4 centimeters. And if LA is perpendicular to CA, name two right angles in the figures. Okay, two right angles in the figures. So let's see, this is a right angle, okay, as well. So that would be angle A and angle H. All right. The triangles shown are congruent, complete. All right. Angle ABD. ABD. Well, how would I figure that out? Well, I do have a triangle here, and I do know that if this is a 90-degree angle, then that's 90 degrees. I know that the two acute angles in a 90-degree or in a right triangle are complementary, so the complement of 40 is 50. Or I know the triangle sums 180, so I could have subtracted 90 and 40 from 180. Either way, I get 50 degrees. Okay. I'm sorry, I went a little bit off on a tangent there. We didn't actually need to know that information yet, I don't think. All I needed to do is name the congruent triangle. So let's see, angle ABD is congruent to, or triangle ABD is congruent to triangle, let's see, that would be C with the 40-degree angle, okay, B, and then D. Notice they share BD as a side. That means segment AB, excuse me, sorry about that, segment AB, first two letters, match it up with the first two letters here, that would be segment CB. DC will match up with D and A, okay, last and first, last and first. Okay. Angle DBA, notice that's backwards in this statement 16, DBA, so I'll name this DBC. If I start with B and then go to A and then D, second, first, third, then I do second, first, third, B, C, D, and then triangle DBC. DBC is again backwards up here, so go backwards up here. That would be DBA. Alright guys, I think that's it. Thanks for watching, and we will finish these last few problems up in class tomorrow.